Hi grade 5s. Today we are talking about mixed numbers and improper fractions. So mixed number is a number that has a whole number and a fraction attached to it. So a way of thinking about this is if I have 3 pizzas and half of a pizza, I don't have quite 4 pizzas, I have more than 3, and this is the way that we would write that. Now you guys have been dealing with mixed numbers your whole lives. Lots of times when people ask you how old you are, you say, well, I'm 10 and a half, or I'm 11 and a half, or maybe you're getting closer to your birthday and you're like, I'm 11 and 3/4. Well, those are mixed numbers. It's the amount of whole years you are, 10, plus a little bit more. Okay, so that's a way of looking at what a mixed number is. It's how many whole things you have plus the fraction or the pieces of another whole thing. You don't quite have 4, but we have more than 3. So 3.5, or a whole number plus a fraction. So that's a mixed number. An improper fraction is when the numerator is greater than the denominator. So up until now, all of our fractions have had a numerator that's less than our denominator, because it tells us how many smaller pieces are in a whole thing. Since the whole thing is the denominator, the number of pieces have to be smaller. But now an improper fraction is when the pieces, we have more pieces than we do denominators. We have more numerators. Okay, so an improper fraction. Now in their book on page 38 and 39, it goes through questions and talking about how to change from one to the other. Okay, we really don't want to have this. We would rather have a mixed number. Okay, you don't say I'm 7/2 years old. All right, you would say I'm 3.5 years old. These are the same number, by the way. Okay, 3.5 and 7/2 are the same number, and we're going to look at that, and the book is going to help us. So we're going to go to our books, page 38 and 39, and I think what we'll do is we will start right on question 2 of page 38. We'll go through a couple of these, and then we'll jump over to the next page, talk about improper fractions, and hopefully get this concept a little bit better in our heads. It can be maybe a little confusing, but it's really not. And what the book doesn't show us is Bubba's little secret on how to make this even easier. So I'll get that at the end. So let's go to question 2 on page 38, and we will start there. All right, let's look at question C, 2 and letter C. It tells us we have 3.5 pies, and it wants us to convert that to an improper fraction. So it wants us to make a fraction out of this where the numerator is going to be greater than the denominator. It's going to be a bigger number. Okay, and then it walks through the steps. Now in question A, it does it for us. So we're going to do the same thing with question C, the one right underneath it. And we're going to follow that pattern, and then we're going to get our answer. So we have 3.5 pies, and it's asking us how many halves do we have all together. Why is it asking us that? It's asking us how many halves we have because our fraction is half. Okay, a few questions down, it's asking us how many fourths do we have. And the reason is because in that question, it's talking about 1 1/4. Okay, and then again, in question I, it's asking us how many thirds. So it's asking us that because this is the fraction, this is how we're breaking up our pieces. So we have pies, and we're cutting them right in half, 2 equal pieces. Well, in 3.5 pies, it wants us to figure out how many halves of pies do we have. So if I have 3 pies, and I cut them in half, how many halves do we have? How many halves do we have? We have 1, 2, 3, 4, 5, 6. So in 3 pies, we have 6 halves. Okay, so we write that in the blank, 6 halves. So over here we have 6 halves. And then it's asking us, so we have 6 halves, plus we have 1 more half. We have another pie, right? Because we have 1, 2, 3 pies, and we have a half. So we have 1 more half that we're dealing with. So we would write 1 plus 1 half. 1 half. So we have 6 halves here, plus 1 more half. Well, what's 6 plus 1? I think you know without even doing a math equation. 1, 2, 3, 4, 5, 6, 7. So in 3½ pies, we have 7 halves. So 7 over 2. Okay? Now let's go on to another question. We'll do question I. All right, question I. It's asking us to change this number into an improper fraction. So first, it asks us, how many thirds do we have in 1 pie? So if I have 1 pie, and it's divided into thirds, 1, 2, 3, how many are there? Well, there's 1, 2, 3. So there's 3 thirds in 1 pie, plus I have another third left over, plus 1 more third. So 3 plus 1 is 4. So I have 4 thirds of pie. So here's the thing. The denominator always stays the same. Okay, we're not changing the denominator. So for our improper fraction, whatever the denominator is in this, it's going to be the exact same in your improper fraction. They're going to be the same. The only thing that changes is your numerator. Okay, so if you're doing a question and you change the denominator, right away stop. Say, no, that's not right. My denominator has to stay as the same denominator, because the denominator tells us how many pieces we're cutting the whole thing into. So we can't change that. So we have 1 1/3, and in 1 pie we have 3 thirds. And since we have more than 1 pie, we have a third of another pie. So we have a third, 2, 3, 4. So we have 1, 2, 3, 4 thirds of pie. So 1 1/3 equals 4 thirds. Let's jump and do one more. Let's do letter D. Okay, letter D says 4 1/8. I'm sorry, it does not say that. It says 4 1/2. Let's change this to an improper fraction. So first of all, we're talking about halves this time. Okay, that's our fraction. How many halves are in 4 pies? So if I have 4 pies, I'll draw it. And cut them all in half. How many halves do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8. The simpler way to do that is go 4 times 2 is 8. Okay, so that's what we're doing. We're multiplying the denominator by this number. This is what we draw to get that, but if you didn't draw the picture, you would just go 4 times 2 is 8. That's how many halves are in 4. Plus, we have 1 more half we have to deal with. We have 1 more half. I don't have this guy, he's not there. So that means we have 4 whole pies cut in half, which means we have 8 halves plus 1 more half equals 9. So we have 9 halves. The denominator stays the same. Okay, now let's talk about, which I just hinted towards, let's talk about an easier way to do this. Now this is a way to convert mixed numbers into improper fractions without drawing pictures. It's very quick and very easy. Easier, I think, than what they're showing us in the book. So we're going to try to do it this way, and if you get this, you will be flying with this. It's so simple. It's basically 2 things. We're going to multiply and add. So we're going to multiply the denominator and the whole number. So basically it looks like this. 3 times 2 is 6, plus 1 is 7. 3 times 2 is 6, plus 1 is 7. So we're going to multiply these, and then we're going to add those. 3 times 2 is 6, plus 1 is 7. The denominator stays the same. 7 over 2. 4 times 2 is 8, plus 3, 8, 9, 10, 11. 11 over 4. 6 times 5 is 30, plus 2 is 32. over 6. See how quickly that happens? It's just simply multiplying these and adding. Multiplying these and adding. It'll work every time. Always keep the denominator the same. And when you have a mixed number that you have to change to an improper fraction, let's make one up. Let's go 3 4/5. 3 times 5 is 15, plus 4 is 19 over 5. Okay, so the key, keep the denominators the same, multiply, add. You'll get it every time. So instead of trying to figure out the long way and draw pictures, if you do this, it'll be very quick, it'll be accurate, and you'll be way more confident. Now we're going to take improper fractions and turn them back into mixed numbers. So go to page 39. We're on question 5. It does the first one for us. It says 6 over 2. Then it shows us a division statement. 6 divided by 2 equals 3 with a remainder of 0. So that means that 6 over 2 equals 3. So they did the first one for us. Okay, now they did the second one for us, and we're going to keep going. So 7 over 2, and I'll write this one out. 7 over 2, and then they break this down. 7 divided by 2. So how many times does 2 go into 7? Well, 2 goes into 7 3 times. 2 times 3 is 6. Doesn't go in 4 times because that would be 8. Okay, so this is where our division and multiplication comes into play, which many of you do very well at. It goes in 3 times, but there's 1 left over, and so it tells you there's a remainder of 1 remainder. So the way to write that is that we have 3 whole, okay, plus 1 half remaining, 3 1/2. So 7 over 2 is the same as 3 1/2. We divide. So we divide 7 by 2. It tells us we get 3 and 1 remainder. Let's look at the next one, C, 7 over 4. 7 divided by 4. How many times does 4 go into 7? How many 4s fit in there? Well, only 1 4. Only 1. 4 times 2 is 8, and we only want 7. So we can only fit 1 4, okay, into 7. But what's left over? Well, we're going to count 4, 5, 6, 7. There's 3 left over. There's a remainder of 3. So to write this as a mixed number, we would write there's 1 whole, and there's 3 fourths left over. Remember, don't change the denominator. 1 3/4. Let's check it, see if we're right. 4 times 1 is 4, plus 3 is 7. Okay, we're correct. Good. Okay, let's look at question E, 10/3. 10/3. How many times does 3 go into 10? So we're going to go 10 divided by 3. Well, let's see. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So 12 is too many. So 3 times 3 is 9. So 3 goes into 10 3 times. How many are left over? Well, 3 times 3 is 9, plus 1 more would give us 10. So there's going to be 1 remainder. So in 10/3, we have 3 whole and 1/3 left over. And we'll check it. 3 times 3 is 9, plus 1 is 10. See how easy that is? It's a very simple way to check it. Question 6, and it's letter C. They're asking us which one is greater. The first two I think are fairly easy. And this one they're trying to trick us. 19 7/8 or 30 1/8. Well, if you look at it quickly, you'll think, well, 7/8 is greater than 1/8. But just remember something. 30 is always greater than 19. So no matter what the fraction is after that, look at the bigger number, okay? The bigger number of whole things. So yes, when you're comparing fractions, the denominator and the numerator, those things you have to look at. But when you're just comparing 2 whole numbers, The greater number is the greater number. Doesn't matter what the fraction is. 19 and 99/100ths is not even close to 30. Okay? So don't let that one fool you. I seen that. I'm like, ooh, they're trying to trick us in the book. Okay. So this concludes our lesson on mixed numbers and improper fractions. Now in your book, I had you 38 and 39. Go back to page 36 and 37. You should breeze through this now. That's kind of the introduction, but I really want you to get into looking at mixed numbers, improper fractions, how to convert them back and forth to each other, okay? So just remember the simple trick is to take your number, multiply these two, and add. So 3 times 2 is 6 plus 1 is 7. Keep the denominators the same. To change this to a mixed number, 2 goes into 7 3 times, because 3 times 2 is 6, remember? And there's 1 left over. So look through your book. If you have any questions, send me a message. And hopefully this makes a little bit of sense to you. It's not difficult once you start practicing it. Practice makes perfect. So keep doing it. There is a question like this on the test if you haven't seen that already. And just keep working. You guys are doing great. Bye.